In this video, we're going to explore the global and non-local keywords in Python. These keywords are essential for understanding how variables work in different parts of your code. By the end, you'll know how to use these keywords to manage variables effectively in your Python projects. So let's dive in and get started. Let's begin by understanding what variable scope means in Python. There are four main types of variable scope. First, local scope, which refers to variables that are defined inside a function. These variables are only accessible within that function. Second, enclosing scope includes variables in an outer function when dealing with nested functions. These variables are accessible within the inner function. Third, global scope refers to variables defined at the module level, meaning outside of any function or class. These variables are accessible throughout the entire script or module. Fourth, built-in scope refers to Python's predefined names such as function names like print or data types like int. These are always available. To determine the order in which Python searches for variables, we use the LEGB rule. Python searches for variables in the following order: local, then enclosing, then global, and finally built-in. This rule helps determine which variable is accessed when you have variables with the same name in different scopes. Now let's take a closer look at the global keyword. The global keyword allows you to modify global variables from a local scope. It essentially tells Python that a variable is defined in the global scope, overriding the LEGB rule for that specific variable. Here is the basic syntax. First, define a global variable. For example, counter equals 0. Then, inside a function, use the keyword global, followed by the variable name to indicate that you are referring to the global variable. For example, global counter. Now you can modify the global variable within the function. For example, counter plus equals 1. When you call the function and then print the value of the global variable, you'll see that it has been updated. Here's a practical example of how the global keyword is used to modify variables. Let's start with a global variable called message and assign it the value hello. We'll define two functions. The first one is called without_global. Inside this function, we create a local variable also named message and assign it the value modified. When we print the value of message inside this function, it will output modified. However, the global variable message remains unchanged. The second function is called with_global. Inside this function, we use the keyword global to indicate that we are referring to the global variable message. When we assign it the value modified, we are actually modifying the global variable. As a result, when we print the value of message inside this function, it outputs modified, and the global variable message is also updated to modified. While global variables can be useful, they also come with potential pitfalls. One common issue is name collisions with imported modules, which can lead to unexpected behavior. Additionally, changes to global variables can be difficult to track across large code bases, making it harder to debug. Global variables can also make code harder to test and create dependencies between functions, reducing modularity. In multi-threaded applications, they may lead to unpredictable behavior if not handled carefully. To mitigate these issues, it's best to use global variables sparingly. Consider using classes or function parameters to pass data instead. Use constants for configuration values to avoid accidental modification. Document global variables clearly to make their purpose and usage clear, and prefer immutable global objects like tuples over lists to prevent unintended changes. Now let's explore the nonlocal keyword. The nonlocal keyword was introduced in Python 3 and is specifically used in nested functions. It allows you to modify variables in the enclosing scope, which is the scope of the outer function. Unlike global, nonlocal targets the nearest enclosing scope rather than the global scope. It's important to note that nonlocal cannot be used at the module level. Here's the basic syntax. First, define an outer function with a variable in its scope. For example, counter equals 0. Then, define an inner function within the outer function. Inside the inner function, use the keyword nonlocal, followed by the variable name to indicate that you are referring to the variable in the enclosing scope. For example, nonlocal counter. Now, you can modify the variable in the enclosing scope within the inner function. For example, counter plus equals 1. When you call the inner function, it will update the variable in the enclosing scope. Let's look at a practical example of the nonlocal keyword, a counter factory. We define a function called create_counter. Inside create_counter, we initialize a variable called count to 0. This variable will be enclosed by the inner function. Next, we define an inner function called increment. Inside increment, we use the keyword nonlocal to access the enclosed variable count. We increment count by 1 and return its new value. Finally, create_counter returns the increment function itself. Now we can create two independent counters by calling create_counter twice. Each counter has its own enclosed count variable, so they can be incremented separately. When we call counter 1, it returns 1. Calling it again returns 2. Calling counter 2 returns 1, because it's a separate counter. And calling counter 1 again returns 3. Let's summarize the key differences between global and nonlocal. Global references variables in the global or module scope, while nonlocal references variables in the nearest enclosing function scope. With global, the variable must be defined before use in the function, while with nonlocal, the variable must already exist in the enclosing scope. Global can create new global variables if they don't exist, but nonlocal cannot create new variables, it can only reference existing ones. Global can be used in any function regardless of nesting level, while nonlocal can only be used inside nested functions. Global is best for constants, configuration settings, and counters across modules, while nonlocal is best for closures, factory functions, and maintaining state in nested functions. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.